All right, this is a video lesson on Pascal's triangle and the binomial theorem. So you want to have your formula sheet handy because we'll be using a formula on there. I want to look at these first and then we'll come back to that triangle. So we're going to expand these expressions, starting with the first one, x plus y to the power 0. Well, we know anything to the power 0 is 1. Here, x plus y to the power 1, well, that 1 is fairly meaningless. This is just 1x plus 1y. X plus y squared, we know when we see squared, it's a good idea to maybe write out the binomial again and do our distributive property. So I get x squared plus xy plus another xy plus a y squared. So I have 1x squared, I have 2xy, and 1y squared. And so if this is x plus y squared, I might as well times that x plus y squared, in other words this, by x plus y again to get x plus y cubed. So I'm going to distribute again and get 6 terms. So I'm going to get an x cubed, a 2x squared y, a x y. Oops, that was squared. I was thinking something was kind of wrong there. There it is, an xy squared. And now the y times everything is going to be another x squared y. This here is going to be 2xy squared. And lastly, a y cubed. And then I'm going to combine a couple of these things. So I have 1x cubed. I have 2 of these here and another one. So that gives me 3x squared y. And I got these guys. So that's 3xy squared. And a 1y cubed at the end. So what we notice here is that these numbers, these coefficients, without the x's and the y's, are in Pascal's triangle over here. So this was x plus y to the power 0, right? And then I had 1x plus 1y to the power 1, 1x squared plus 2xy plus 1y squared, and so on. Okay, and then we have the third one, to the power 3, that expansion as well. And hopefully what you can see as a pattern in here is that this number is the sum of these two, and this number is the sum of those two. So I look sort of up to the right and the left to get the sum for the next row. So if we were to add a row or 2 to this, I would have the 1s cascading down the side. This would be 4. This would be 6, because I've got 3 and 3. And then 3 and 1, that would be 4 again. So I have 1, 4, 6, 4, 1. Another row, there's a 1. This is a 5, a 10, another 10, a 5, and then a 1 on the outside. And so that's Pascal's triangle, and that's the pattern. And so if we look at it in using combination notation, the first is 0, choose 0, which is 1. 1, choose 0, 1, choose 1, which is in both cases 1. 2, choose 0, which is 1. 2, choose 1, which is 2. And 2, choose 2, right? That's these numbers here, 1, 2, 1, 1. This is 2, this is 1, and so on. So 3, choose 0, 3, choose 1, which is 3. 3, choose 2, which is also 3. And 3, choose 3, which is 1. And that would be this circle. So we can use combination notation to get those layers of Pascal's triangle, which are the coefficients in the expansion. Okay, so on this slide we can see that we have the binomial x plus y to the power n, so n is our exponent, is expanded and simplified. So n is equal to 0, n is equal to 1, n is equal to 2, and so on. You get these expansions. And so here's some conclusions. So this might be a good point to pause the video and make sure you have all of this information in your notes, because these will be important things to note. Okay, so the first one, there are always n plus 1 terms. So that's saying that in our expansion, where n is the power, like x plus y to the power 2 is x squared plus 2xy plus y squared, which we saw. This is n, and there are 3 terms. Okay, and we saw the same with, if it's cubed, there are 4 terms, and so on. So that's an important thing to note. The sum of the exponents in each term is always n. So here I have a 2, 1 and 1 is also 2, and then that's 2. The exponents of the first term, the x, go down from n, which is 2, to 1, and then it disappears to 0. And y isn't here, then y to the power 1, y squared, so they go in the opposite direction. And the coefficients are the numbers from Pascal's triangle, which we know we can get using our combination formula. So if we write this expansion using combinations, we're going to use this. The first one, we're going to write 5, choose 0, which is 1, x to the power 5, y to the power 0. So I'm not even going to bother writing that. Plus 5, choose 1, x to the power 5 minus 1, which is 4, y to the power 1. So you can see I'm using these digits in the powers. Plus 5, choose 2, x to the power 5 minus 2, y to the power 2. So 5 choose 2 is 10, 5 minus 2 is 3, and then there's my y squared, and so on. So 5 choose 3, which is also 10, x to the power 5 minus 3, which is 2, y to plus 5 choose 4, which is 5, x to the power 5 minus 4, which is 1, and y to the power 4, and that's this term. And the last term, 5 choose 5, x to the power 5 minus 5 is 0, that's why it's not here. 5 choose 5 is 1, and y to the power 5. So that's this term. Okay, so this is what you have on your formula sheet. This formula here, and so we're going to go through and use that and see how to use the formula to find different terms in our expansion. So this x is our first term in the binomial. That's this guy, first term. Y, the second term, is here. N, which appears in a couple of places in the formula, is the exponent. That's n. And k is specific to each term. So k is specific to each term. And the other thing is that we notice it's listed term k plus 1. So if I was looking, say, in this example, say if I was looking for term 3, that is term k plus 1, then k would be equal to 2 if I'm looking for term 3. N, in this case, is 4. X is actually 3x, and y is positive 2. So let's actually just try finding term 3. So term 3 would be n, which is 4, choose k, which is 1 less than the term, so 2, times x, which is actually 3x, and we want to use brackets here, to the power n minus k. N is 4, k is 2, so this is actually just going to be 2, 3x squared, excuse me, times y, which is 2 in this case, to the power k, which is also 2. So 4 choose 2, that's 6, times 3 squared x squared. Remember to apply this exponent here and here, times 2 squared. So if I put that in my calculator and multiply it out, or I end up with 216x squared. Okay, and so that's how I use the formula. I like to write down what's k, what's n, what's x, and what's y, and then it's just a matter of putting all of that into the formula which is on our sheet. So this is really just a procedural sort of thing. So why don't you try this one? We're looking for the 7th term, so we're looking for term 7. What does that mean about k? What's n, what's x, and what's y? So x is 4, y is negative 3x, n is our power, which is 9, and k is 1 less than the term, so k is going to be 6. So maybe pause here and give that a shot. All right, so hopefully here to find term 7, you did something like this. Term 7 equals n choose k times x to the power n minus k times y, which in this case is negative 3x to the power k. So this is 84. This is 4 to the power 3. And this, notice I've got a negative base. That's why I'm going to use brackets, because when this is even, that negative is going to disappear. And this is going to be 729x to the power 6. And so if I multiply all this together, excuse me, the 7th term is 3,919,104, pretty big number, x to the power 6. Okay? Moving on. Here we've got 2 examples. This one says the binomial 3a squared minus 2 to the power 3k minus 2. Maybe not the best variable to use up there because k is used in our formula, but anyways. So this is expanded, and there are 12 terms. So what does this mean? There are 12 terms. Remember back from our conclusions what we said about the number of terms in the expansion. The number of terms is equal to n plus 1. So that tells me that n is 11. So I know that this is actually 11. So what's the value of k up there? Well, 3k minus 2 is 11. 3k is 13. So k is really 13 on 3. And that's our value. All right, in this one, we're looking for the middle term. So I think about what that means in this expansion. So here, n is 6, which tells me there are 7 terms. So that's relating to the same idea that we saw in this previous example, right? That the relationship between the number of terms in n is that n plus 1 is the number of terms. So here, if n is 6, that is 7 terms, and the middle term then must be term 4. So I'm really looking for term 4. So if I'm looking for term 4, and I write out all my information, x is x squared in this case, y is negative 3y. Think about what k is if I'm looking for term 4. Well, k is 3. So now, I put all those things in my formula. N choose k times x, which is actually x squared, to the n minus k times y to the k. And now this time, notice I've got a negative base, but the power is odd. That means my answer is going to be negative for this example 4. So 6 choose 3 is 20. This is x squared to the 3rd power, so that's x to the 6th. Negative 27, right? That 3 applies here and here. And so if I multiply all this out, I get that term 4 is negative 540 x to the 6th y cubed. So that's a common question to find the middle term. Okay, 2 more. So example 5, determine the value of a in this binomial if one of its terms looks like this. So this doesn't tell me what term number this is, but I've got some hints in here. I know that the power on the y, because this is y. Over here, if this is y to the power 3, that's really k. And the other thing that I know is that I would have x, this part. Sorry, I know that if I look at the power on the x, which is 5 in the the term in the expansion, x, this ax is going to be to the power 8 minus k, which is 3, which is 5. So that's where that comes from. So again, using those conclusions are important here. If I just clean this up, we can find that term. So we said that k is 3, n is 8, right up there, x is ax, and y is negative 2y. So now I'm going to put those things into my formula. So term k plus 1, so term 4, this is term 4. So that's negative 14,336. X to the 5th y cubed is equal to n, choose k, times x, which is actually ax, to the power n minus k, and negative 2y to the power k. And now, 8 choose 3 is 56. A to the power 5, x to the power 5, times negative 8 y cubed. And what I might do is just cancel this, and this x, and that. And so I'm left with negative 14,336 is negative 448 a to the power 5. And now I can isolate this by dividing out negative 448. So if I do that on both sides, I get 32 equals a to the 5th. And then I'm going to take the 5th root of both sides to get a. And if you remember how to do this on your calculator, great. If you don't, you put in 5, then you hit the math button, and you want to pick this. And that 5 will pop in where the x is and become the index, and then you type in 32, and you get 2. So the value of a is 2. There we go. A little bit different style of question, right? We're not just sort of a robot going through the motions of the formula. And this one, the last example, is we want to find the numerical coefficient of the term x to the power 4 in our expansion for this binomial. So it doesn't tell me what term number that is. So I know that x is x squared, I know that y is 2x, and I know that n is 3, and I know that my term will have an x to the power 4. So if I forget about the coefficients for a moment, and I think, okay, if n is 3, I'm going to have my x, which is x squared, to the power 3, and then I'm going to have, in the next term, that power 3 is going to decrease by 1, and the value of y, which is actually 2x, is going to be there to the power 1. And then in the next term, I'm going to get x squared, and this power goes 3, 2, 1, and my 2x is going to go up by 1 from 0 to 1 to 2. So if I look at what the power on the x's will be, this is going to be x to the 6th. This is going to be 4 plus 1 is x to the power 5. And I'm ignoring the coefficients and so on here, guys, but just looking at the powers of x. X squared and another x squared. This term 3 is going to have x to the power 4. So I'm looking for 3, which means that k is 2. So term 3, I need to find to determine what the coefficient is. So n, which is 3, choose 2, choose k, times x, which is x squared, to the 3 minus 2, times 2x to the k is going to be 3 times x squared, because this is just 1, times 4, right? That 2 applies here and here, don't forget that, x squared. So I really get that term 3 is 12x to the power 4. So my coefficient that I'm looking for is 12. Determine the numerical coefficient. It is 12. There you have it.